Chapter 4.3 is a separate lesson. We grouped 4.1 with 4.2, and we're going to group 4.4 with 4.5 and 4.6. But 4.3 is a lesson in and of itself, because now what we're going to do is we're going to figure out how do we factor a trinomial in the form of ax squared plus bx plus c, where there is a number before the x squared term. And there is an extensive explanation of all that in Chapter 4.3. There is more than one method to approach this, and I've taught all methods over the time that I've taught this course. However, what I've discovered is that my students seem to gravitate to what I call the AC method. If you want an explanation of the AC method, just turn to page 259. But that's the only explanation I'm going to give you. If you would like to use another method other than the AC method, then you may do that as long as you know what you're doing, and you may want some help. You can ask me or you can ask someone in the Learning Center. But let's go ahead and take a look at the AC method. In the AC method, what I'm going to do is I'm going to take the antecedent to the variable in the first term, the A, and I'm going to multiply that by the C. When I multiply those two together, I'm going to come up with some number, and then I'm going to use that number in calculating what the B should be. First, we want to review our patterns, and notice in the first one everything's going to be positive. The only difference between that and lesson 4.2 is there could be some number in front of the x variable. In the second pattern, the two terms are going to be separated by negatives, and there could be some number in front. That's why I've got the blue marks. The third and fourth pattern, positive negative or negative positive. I need to do a demonstration of each one of those in order for you to clearly understand what I'm talking about using the AC method. So in our first one, let's take a look at problem number 86 on page 263. There we have 16x squared plus 32xy plus 15y squared. Now everything's positive through there. When I say AC, what I'm talking about then is the 16 and the 15. All right? So if I take and I multiply 16 times 15, what I come out with is 240. Pretty powerful number. Now I want to take that 240 and I want to say, what two numbers when multiplied together will give me 240 and when added together will give me 32? All right? Well, obviously 240 and 1 won't work, or 122 won't work. But what if we took 24 times 10? Well, that's 240, but when added together, that gives me 34. Well, what if we took 30 times 8? Well, 30 times 8 is 240, but when added together, that gives me 38. So it's got to be something smaller than 24, because if I'm multiplying 30 times 8, I'm getting 38. 24 times 10, and when I add, I get 24. Let's try something smaller than that. What if I take 20 and I multiply that by 12? There we go. What we now have is those two numbers, when multiplied together, give me 240. But when I add them together, I get 32. This is our key combination. How do we get that? Again, we multiplied the first term times the last and got 240. Then we had to factor that 240. This is what's going to take so much time. But now we know that it's 20 and 12. So what I'm going to do is I'm going to erase some of the stuff that we put up here. Knowing that it's the combination of 20 and 12, now what I do is I rewrite this and I put it into 4 terms. I have my 16x squared, but now I say plus 20xy plus 12xy plus 15y squared. All right, now I'm going to erase that 20 and 12, okay? What I've now done is I've set up 4 terms. And I have those 2 terms in the middle. When combined, 20xy plus 12xy gives me my total of 32xy. What I'm going to do now is that factoring by grouping that we did once before. And so I'm going to separate the first 2 from the last 2. All right, factoring out a common term there. All right, in the first 2, the numbers 16 and 20 can both be divided by 4. And I have an x squared and an x, so I can factor out an x. And what do I have left? 4x plus 5y. Now in the second one, what can I factor out of there? Well, I can factor out a y, and the number 3 divides evenly into both 12 and 15. So I'm going to factor out the 3 and the 1y. What does that give me? That gives me 4x plus 5y. And now we see we have that common term, 4x plus 5y. So when I regroup, I get 4x plus 5y. And what I have left is 4x plus 3y. But I know some of you are asking the question, well, what if you didn't put it the way you did? What if you rewrote that thing, and instead of putting 16x squared plus 20xy, you put plus 12xy. And then you put the plus 20xy, and then plus 15y squared. Would that work? Or does it make a difference? I mean, it should make some kind of difference, but let's see if we can solve the problem if we put those in reverse order. Well, if we separate the first 2 terms again, right here, what do we have in common in that first term? Well, I know 16 and 12 can both be divided by 4, and I have x in both of them, so I'll put x. And what do I have left? 4x plus 3y. And in the second one, now I have a 20 and I have a 15. Both of those can be divided by 5. And I have y's in both terms, so I can pull that out. And what do I have left? 4x plus 3y. And notice, now I have a common term. That common term is 4x plus 3y. And what do I have left? 4x plus 5y. How does that compare to our first answer? Well, actually, they're identical. It's just that we flipped the terms. In our first answer, we had 4x plus 5y. And now in our second answer, we had 4x plus 3y. But our second terms are the flip of each of them. And it doesn't really matter which way you write it. So in fact, when you split those apart, it doesn't matter whether you put one in the first or the other one first. You should end up with the same answer. Now in the book, it gives it only one way. But just remember, if yours turns out to be just the opposite of that, as long as you've got the 2 correct binomials, you're in great shape. All right, so now let's take a look at the other 3 combinations using the AC method to solve these problems. For our next one, and I think what I'm going to do is we'll keep that AC there. A times C. Let's look at problem number 98. That's on page 263. That is 14x squared minus 20x plus 6. That's the correct format. And so when we multiply AC, we're multiplying 14 times 6. In this particular case, then, 14 times 6 gives me 84. Now, what two numbers, when multiplied together, give me 84, added together give me 20? Well, obviously 84 and 1, or even 42 and 2 isn't going to work. So let's try if we divide both by 4, and we're going to get 21 times 4. Well, 21 times 4 still isn't going to work. So what else have we got available to us? Well, how about if we divide both of those by, if we divide 84 by 6, what we'll end up with when we divide it by 6 is 14 times 6. 14 times 6. That's what we had before. 14 plus 6 gives us 20. So that's the combination. We had it right there in front of us. So let's rewrite this now as 14x squared. And now we know that it doesn't matter whether we put the 14x second or third. So we'll put it minus 14x minus 6x plus 6. In our first two terms now, what we can pull out, that's these two right here, what we can pull out is 14x. And what do we have left? X minus 1. In our second two, however, if we just pulled out 6, then we'd have negative x plus 6. We want it the other way around. So what we're going to do is we're going to pull out that negative. That's why we had that lesson earlier on pulling out a negative factor. If we pull out a negative 6, what we have now is x minus 1. Just remember that sign changes when you pull out the negative. Now what we end up with is x minus 1 times 14x minus 6. So now we've solved one for the second pattern. Let's go ahead and move on to the third pattern. So I'm going to erase this so we can have some space. Keeping our AC there. In the third pattern, let's look at problem number 76. In 76, what we had is 12x squared plus 11x minus 15. When we multiply our A times our C, which is 12 times 15, what we end up with is 180. All right. Now, this time, because the C is negative, we're looking for two numbers when multiplied together give us a difference of 11. So, obviously, we could multiply 18 times 10. The difference there is only 8. That's not going to work. So let's try something different. Well, what if we divide 18 by 2? If we divide 18 by 2, we'll get 90 and 2. That's not going to work. But if we divide that 18 by 20, or let's divide it by 9. If we divide by 9, what we get is 20 times 9. Oh, 20 times 9. The difference between that happens to be 11. So now we're in. We know that. And it may take you a while to look at those and come up with the factors. I try to use the ones that are easiest first, but it doesn't always work that way. For example, notice 15 times 12 gives us 180, but you're going to have to be messing around for a while to know those kinds of things. So try those. Anyhow, now we have the pattern. So what I'm going to do is I'm going to put 12x squared. And what I'm going to do is put plus 20x. So now, because I have to come up with 11x, that means this is going to have to be a minus 9x minus 15. Just remember, in that third and fourth combination, once you put that down, because we're looking at the difference between the two, we have to have 20x minus 9x to get our 11x. Now what can we factor out of the first two again? We're going to split this apart. We can factor out, well, 4 goes into 12, it also goes into 20, so we'll take a 4. And we've got an x there, so we've got an x. And what do we have left? We've got 3x plus 5. Now in the second one, we have a bunch of negatives. Now we want positives because that's all we've got over there. So what we have to pull out of that is a negative. And what can we pull out of that? Well, 3 is the only thing we can pull out of that. When we pull a negative 3 out, now we end up with 3x plus 5. And there we go. We've got our common factor of 3x plus 5 times 4x minus 3. And we have that pattern that we had right there at the beginning. So now we've solved 3 of the 4 patterns. We just have one more to go. We'll try one more example. And that last pattern, the one we find in the book, happens to be problem number 88. So problem number 88 follows the pattern because it has 15x squared minus a single xy. And now they've thrown that old y factor in there. But we don't care about that for right now. Minus 6y squared. We got our last pattern. Our a times c is 15 times 6. And that equals 90. Okay? 90 times 1 won't work. 45 times 2. I'm looking at that and saying, yeah, but I know what combination makes 90 that's pretty easy. And that's if I multiply 10 times 9. And as a matter of fact, that does work because the difference between 10 and 9 is just 1. So when I rewrite this, I'll rewrite it as 15x squared minus 10xy plus 9xy minus 6y squared. Now we're going to factor by grouping again, taking the first two. What we get is we can pull out 5 and we can pull out an x. And what we end up with is 3x minus 2y. In our second one then, if we pull out a plus 3y, we end up with 3x minus 2y. And now we have that factor that's common to both, 3x minus 2y times what's outside the quantities there, 5x plus 3y. So there you have an example of all 4 patterns. I want to take a look at just one more problem. And that problem happens to be problem number, I think it's 98. Yeah, I want to take a look at 98 for just a second because it has 14x squared minus 20x plus 6. All right? I'm going to erase our AC there. What you can multiply 14 times 6 and you can go through the whole process and you'll get the correct answer, but what they want you to do is always look for a common factor. So you see in number 98, we'll have a common factor. Even in number 104, we have a common factor. And I'm sure on one of the homework problems, you probably have a common factor that you can pull out of there. In this particular case, the common factor happens to be 2. If I pull that out, I get 7x squared minus 10x plus 3. All right, using the AC method now, I'm multiplying 7 times 3, and I get 21. Now, that follows pattern number 2. So what two numbers, when multiplied together, give me 21? When added together, give me 10. And we've already got them right there, 7 and 3. So when I do this again, I will take 2 times the quantity 7x squared minus 7x minus 3x plus 3. And this is a whole lot easier. So now I get 2 times 7x times the quantity x minus 1. And I pull out a negative 1. I'm sorry, take that back because it's 3. I'm going to pull out a negative 3 and times the quantity x minus 1. And now I put that whole thing in parentheses, so I have 2 times x minus 1 times 7x minus 3. So what they're trying to teach you here is make sure you look for a common factor that you can pull out before you start doing the factoring.